everyone, it's Justin again. In this lesson, we're going to continue working on proofs with lines and angles by completing a more complex proof together. You'll want to have your property review activity nearby for easy reference throughout both this video and the practice afterwards. By the end of this lesson, you will be able to complete complex proofs involving line and angle properties. First, we'll write a flowchart proof, and then we'll write a finalized two-column proof. Here's our complex proof about angles and lines that we'll complete together. The problem says, given that P is parallel to R, prove that angle 1 and angle 3 are supplementary. We also have a picture here with lines P and R and 3 angles labeled 1 through 3. Keep in mind that there are many ways that you could go about doing this proof. Our flowchart can help us visualize different approaches and will help us create the final two-column proof. I could start by annotating my picture, so let me add in some arrows to show that my lines are parallel, but that's all I have for this so far. Before we even start making our flowchart, let's take a minute to think about this. I'm going to write this all down to help you follow along, but this might be something that you want to do in your head at the start of each proof if you don't want to write it out. I have 2 parallel lines here, and a line that goes through them, so that means all of my theorems and definitions for parallel lines and transversals are in play. That gives me a lot of angle relationships to work with. Ultimately, my goal is to prove that angles 1 and 3 are supplementary. Look back at those parallel lines and transversal properties. Is there anything that gives us a relationship between angles 1 and 3? Unfortunately, no. There is no relationship directly between them. When there's no direct relationship between 2 angles that you want to be able to make a statement about, you can always find a third angle that they each have a separate relationship with. What this lets us do is find common ground between our angles so that we can start connecting them to each other. This same concept also works for segments or figures as well. In this case, since I can't relate angle 1 directly to angle 3, what's a third angle that they both have a relationship with? Actually, there are many answers to this question. All of these circled angles would work, but the only named angle in our picture that fits is angle 2. So let's just use that one for simplicity. Take a moment to find what relationship there is between angle 2 and angle 1, and between angle 2 and angle 3. Angles 2 and 3 are consecutive interior angles, and angles 1 and 2 are vertical angles. Now our goal is to use both of these relationships to bring angles 1 and 3 together. We also know that line P is parallel to line R, which is going to be key for being able to actually use the theorems related to consecutive interior angles. Let me give you some help to get you started. Here's the outline of what your flowchart should look like by the end of this proof. Notice that on the screen, my flowchart is horizontal, but in your Notes template PDF, yours is vertical. The orientation of the flowchart is not what matters here. What does matter is how the bubbles connect to each other. So we'll be focusing on those arrows. Pause the video here and try to fill in the rest of the flowchart on your own. Let's go through this top to bottom and left to right. First, the reason that P is parallel to R is just that we were given it. The reason that we know angles 2 and 3 are consecutive interior angles is from the consecutive interior angles definition. Because I know both of these things, I also know that angles 2 and 3 are supplementary from the consecutive interior angles theorem. The reason that I need to go further with my supplementary angles is because eventually I want to be able to relate angles 1 and 2 to angles 2 and 3. The only way for me to do that is with either properties of congruence, like the transitive property of congruence, or properties of equality, like the transitive or substitution properties of equality. So I'll need either an equation or a congruence statement to do that. Here I can make an equation by saying that the measure of angle 2 plus the measure of angle 3 is 180 degrees because of the supplementary definition. That's as much as I can say about angles 2 and 3, and I've run out of space in this branch of my flowchart. On to angles 1 and 2. We know that angles 1 and 2 are vertical angles because of the vertical angles definition. Then we know that angle 1 is congruent to angle 2 because of the vertical angles theorem. Now this checks out. We have an equation about angles 2 and 3, but a congruence statement about angles 1 and 2. Well, that won't work to compare. We need them to both be in matching forms, so we can say that the measure of angle 1 is equal to the measure of angle 2 because of the congruence definition for angles. Now we have two equations here, so we'll be able to compare them. This is exactly where we were trying to get to, because now we can use those properties of equality to bring together angles 1 and 3. Now I can swap out angle 1 for angle 2 to say that the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. That's the substitution property of equality. All right, I'm almost there. We know that this means these angles are supplementary. But we're not done yet because our final statement needs to exactly match what we were told to prove. So my very last bubble should say angle 1 and angle 3 are supplementary because of the supplementary definition. Wow! This proof was no joke. We have 9 different steps. We still need to turn this flowchart into a 2-column proof, but first I want to point out a couple of interesting things that happened here. First, did you notice that we used the supplementary definition in 2 different ways in this proof? Here we used it to make an equation from the fact that 2 angles were supplementary. And here we used it to state that 2 angles were supplementary from the equation. This calls back to what we learned in our last unit. All of your definitions are biconditional, so you can always use them in 2 different ways. Second, a few lessons ago, I pointed out that you'd commonly find yourself writing 2 statements about the same thing. One with a definition first, and then one with a theorem second. We had to do that here twice. We did it for consecutive interior angles, definition first, then theorem, and then also for vertical angles, definition first, then theorem. This is because we need to state that we have an angle pair before we can go making statements about the relationship between those angles. To turn this flowchart into a 2-column proof, let's number each of these statements. I'm going to number them in the order that I originally wrote them down. There are way too many possible correct arrangements of these 9 statements for me to show them all to you this time. Instead, let's do a little bit of analysis. Here are 4 possible orders for these 9 statements. Pause the video here to decide whether you think each of them would be correct or incorrect. B and C are correct, while A and D are incorrect. Let's look through A and D to see what went wrong, starting with A. The problem here is statement 4. See how in my flowchart, I need statements 1 and 2 to get to 4? That means 1 and 2 both have to come before 4 in my list. But here, they come way after it. That doesn't logically work. Let's look at D now. The problem here is statement 6. See how in my flowchart, to make statement 6, I need statement 3 first? But 3 comes after 6 in this order, so that also doesn't work. That leaves us with these 2 correct orders. These are definitely not the only 2 correct ways to order these statements, so if you have another idea in mind, you can always check your logic the same way we just did to make sure you're correct. To make my 2-column proof, I'm going to use this order. So let me put that up top here and clear out some space to write my proof. Okay, so we want to put our statements in our 2-column proof from 1 through 9. Now that you've had some practice writing 2-column proofs, try to write this on your own, and then we'll check your work together. Here are each of my lines in order with the flowchart bubbles that they came from. If you've also done your proof in the same order as me, yours should match mine. And that's it. We have successfully proven that angles 1 and 3 are supplementary with a 2-column proof. Now you can write complex proofs involving line and angle properties. We went through a couple of good tips in this video that will work for many types of proofs. First, if you need to use a theorem about a particular type of line or angle, make sure you have the definition first in your proof. Second, always double check the logic of your 2-column proof order by making sure all lines needed for a new statement come before it. You will have both multiple choice practice on the website and written practice in your notes template PDF for this lesson. The written practice will come first, so make sure you do the additional practice and the 2 in your notes template PDF before you move on to the multiple choice practice game on the website. See you next time!